So, okay. Measures of central tendency, I probably should have drew the line there for those. But measures of central tendency are trying to look at what's a number, kind of like Lord of the Rings, the one ring to rule them all. You know, it's like what's one number that kind of represents the whole data set. And mean and median for sure are going to be that. Mode, maybe. Okay, mean is what math people call?
Mean.
Average. So when you're finding the mean, you're just finding the average. And really for that, we just take and add all the numbers together. We call that the
average
sum of the numbers divided by the number of numbers. So if you do the sum of the numbers divided by the number of numbers. So for this one down here, if I want to find the average, I would do 5 plus 3 plus 7 plus 13. So 28, I think that is. I got a yes, so I'll go with it. And there's 4 numbers there. So 28 divided by 4 is 7. That work for you?
Yep.
Often it'll be a decimal. This time it wasn't. Median, you also see the word median when they're talking about roads, and the median is the middle. So the median is going to be the middle number. And it's possible that sometimes like this, so is my middle number, okay. It's possible you'll have 2 that tie for the middle, right?
Yeah.
So if 2 tie, we
add those 2 up and divide by 2.
Perfect. So if, what did I write here? So average, middle 2 numbers, if 2 tie for the middle. Maybe I should try to sound all like eloquent, like if you have a data set with an even number of values, then you're going to get like these 2 that tie in the middle. So this one here, do I average my 3 and my 7? No! What do I have to do first? Trick question.
Put them in order.
Put them in order, exactly. So you have to do 3, 5, 7, and 13. So first thing is you have to put them in order. Should we add that to the notes somewhere? Are you guys good?
No.
Middle number. Maybe I'll say middle number when in order. When in order. So our median now is right between that 5 and that 7. So we average them together. 5 plus 7 divided by 2. Most of us probably just look at it and know the answer is 6, right? But if I do that, then if you had 2 crazy numbers, 13.7 and 23.812964, you'd know how to do it. Just average the 2 together. Mode is the most common number. If you have 2 numbers that tie for most common, so then you'll have 2 modes. So if you have a data set, something like, I don't know if I'd mess up your notes with this, but something like this, and then we'll maybe say another 3 and another 7. Now the mode is going to be 3 and 7. Good? There's at least one in the homework that has this line here. If no number is most common, so kind of like that problem before I started messing with it, where you just have 3, 5, 7, 13. Is there a mode?
No.
Nope. So if no number is most common, there's no mode. But if you have 2 numbers, like the one I did before where now I had my 3 and my 7, now you have 2 modes because there's 2 that are more than everything else. But if they're all just the same number of times, no mode. We okay on those? Cool. Range. Range shows how spread out the data is. I think that's what I have in my notes. Yep. So range shows how spread out the data is. So if we're talking about ages in here, and we want to figure out what's the range of all of our ages, we would do the largest number, which would be mine. Minus the smallest number. So always big minus small. Then you'll get a positive number for the range. We okay for range? If you wanted to go back to that data set we are half-heartedly doing here, you have to do the 13 minus the 3 to get a range of 10. Good? Then, outlier. Something's an outlier. A data value that is nice, very different. Just trying to figure out what fit the blanks. Very different than the other values. So if we were talking about ages, I would be the outlier. You guys are all probably within a year or so of each other. Then you throw me in here, my whopping 27 years old. 43. But, you know, it's like, that's just way, because you guys are all like, what, 13, 14? 13. So maybe a 15 or something in there.
Sam's 15, Pierce is 17.
If we were to take, if we were to think back through, focus, okay, an outlier. If you throw my age and your ages together, is that going to impact the mean?
Yes.
Yep. You throw a 43 in here with a whole bunch of 13s and 14s, like, oh, the average age in our class is 14.7, you know, or maybe 15.2, and there are no 15-year-olds. Is it going to mess up the median? No, because if you put them all in order, my 43 is just going to be hanging out here at the end. And, you know, it might slide that middle number over a little bit to the right, but the fact that one is way bigger doesn't mess up the rest. Fair enough? So back down to outlier. Messes up the mean. Is that what I want to say? The mean and the range. Because now your largest number is way bigger, or maybe it's your smallest is the outlier. Little or no impact on the median and mode. That our mode is probably still going to be 14 for here in the room, even though the number is way bigger. Ready for the next page? Box and whisker plots. Shows the spread of the data. Shows the spread of the data. And this here really is just a ginormous median question. That if I were to take and write these in order, I found often people make mistakes in that they just miss one of the numbers. So as you go to write them in order, I would encourage you to consider at least underlining them as you go. Because I found that that's probably the most common mistake I see on people's tests or quizzes. They just miss one number. So 45, 48, and 75. So I don't know if you copied mine or did the other. But if we were to do that, now our middle number, you could take, and so that one, that. Some people count and divide, some people cross off. 23, do you agree that's going to be our middle number? So box and whisker plot, if we take 23, so my 25 is right there, halfway between 0 and 50. So I'm going to put a line right here. Oh, I'm going under the assumption that you guys pretty much remember these. Is that true?
Yeah.
Okay. Maybe let's keep drawing. And I'm going to write the 23 right underneath it. You could put it up above if you don't have room. But basically what we're trying to do is we're trying to take the data, we're trying to break it into 4 chunks. And each of these 4 chunks has the same number of numbers in it. So now that we have kind of our median right there, we want to take the bottom half. And, well, so as we have that 23, we just kind of ignore that now. And we say, okay, now these bottom 4 numbers, my median of those is going to be 16. Agreed? So the 23 is the middle part of my box. 16 is going to be, so I have 10 right there, 20. So 16 is going to be right about there. And that's going to be kind of the lower end of my box. So I'll call that the lower quartile. And now now I can take this upper 4 numbers. Do you agree my median's halfway between 45 and 48? Yep. So 46.5. So 40 is there. So 46.5 is a little over 45. So 46.5, label that. And now what we have is so far, we're not done quite yet, but we have the middle half of the data. So we know 25% of the data, because we cut it in half in the middle. 25% of our numbers are going to be between 16 and 23. Another 25% is between 23 and 46.5. So the numbers are a lot more spread out between 23 and 46.5. Agreed? And now, because we know that's going to be half of the lower half, this is half the upper half. Now we just go through and we put in our whiskers, so that's the box part. We go down to the 10, so that's the minimum. So we put a 10 and then connect it with a bar like that. And then 75. So I believe that'd be my 75 mark. And so that's the maximum. So what's nice about a box and whisker plot is you can quickly look at it and see, all right, what do our numbers look like? The smallest number is this 10. The biggest number is the 75. So you can see the range of the data, how spread out is the data. But you can look and see, most of the numbers are bunched up right in this area. So 10 to 23 is most of it. These are a lot more spread out than the rest. kind of good for box and whisker? So when we do this thing with Blandford data, box and whisker might be nice to look at how does this apply to months or to something. You might want to do some of those. This bottom one, I don't know if you want to go through and do the whole thing. I really just want to show what happens in the middle part. And it'd be this. I have an even number of data points here. So let me start at the bottom. So I have 15, 18. Oh, I put them all in order. Sweet. Okay. So they're already in order. I tried to save time a little bit. The middle part is going to be, so I have 1, 2, 3, 1, 2, 3, 1, 1. Okay. So our median is going to be right there between 45 and 65. So we know our median is going to be 55. So that's going to be the center of my box, yes? This is the part I wanted to make the distinction of. If you have, like this one up above, if you have just one number that's the median, you kind of throw that number out when you're looking at what's the median of the bottom half. You throw that number out when you're looking at what's the median of the top half. Fair enough? So if you just have one number that's your median right there, it's kind of like you just gone, as you're figuring out your lower quartile, they call it, and your upper quartile. When we're in a situation like this, because it's right in the middle, now we're going to include the 45 when we're looking at what's the middle of these, include the 65 when you're looking at what's the middle of those. So I guess it won't be that much more work to finish it off. The median in my bottom half is 27. So I have 10, 20, 30. So 27 is going to be right about there. So that's the bottom half of my box. So 25% of the data is in there. The 70 is my upper half. So I have 50, 60, 70. And so my upper quartile, they call it, is 70. Then you could go through and put in the maximum is about a 92. The maximum is a 92, should be about there. And minimum of 15. Cool. Make sense?